All right, hello everyone. So today we're working with a precalculus problem. We have find the vertical and horizontal asymptotes for the following rational function. So we have y equals quantity 2x squared minus 7x plus 5 divided by quantity x squared minus 8x plus 7. All right, now what I'm about to go over is this is like just a general way of going over or finding vertical asymptotes for a rational function. A rational function is basically one polynomial over the other. Here's how we do this. You're going to go ahead and try to factor your polynomials as much as possible. You're going to do this for the numerator and both for the denominator. And what we're going to do after that is we're going to cancel any terms that are in common. The terms that cancel are basically what we sometimes we call them holes, or we'll refer them as the places that where holes occur. And the terms that don't cancel, they give us our horizontal asymptotes, or vertical asymptotes, by setting the remaining term equal to 0. Okay, so they give us our vertical asymptotes by setting the remaining term equal to 0. Now, sorry, I know that's a bunch of words, so let's actually put this into practice. So first of all, I'm going to start factoring this function. So the numerator would factor out as 2x, and yeah, I would stop the video just so you can get some practice. If you need some with the factoring, it would factor as 2x minus 5 times x minus 1. And then the denominator will factor out as x minus 7, x minus 1. Okay. And what happens here is the x minus 1's cancel and go away. And you would have a location of a hole is located at when x minus 1 equals 0, or in this case x equals 1. For your vertical asymptotes, those occur for the remaining part that on the denominator that's not been canceled, so the x minus 7. So what you do for the vertical asymptote is you basically just take that denominator, that part of the denominator that's left, that x minus 7, the part that did not cancel, and you set it equal to 0. So x minus 7 equals 0, x equals 7, and there you go. And that's it. That's always how it works when you're working with two rational functions. You factor as much as possible, you cancel whatever makes the canceling parts equal to 0, that's where you have a hole, and whatever is left in the denominator when you set that equal to 0, the terms set them equal to 0, that's where your vertical, and you solve, that's where you have your vertical asymptotes. Okay, now some issues that sometimes come up with these, depending on the degree, meaning like the highest power. If it's a cubic, for example, the factoring can get a little messy on those. So just be aware of that. But yeah, factoring is the key here. Now, the next thing I want to go over is to find horizontal asymptotes. For a rational function, there are two times this can happen. Okay. The first case, number one, is when the degree of the numerator equals the degree of the denominator. So the highest power you see on the numerator is equal to the highest power that you see on the denominator. You'll have a horizontal asymptote then. And the asymptote here is equal to what I have here in red. And it's y equals the leading coefficient of the numerator divided by the leading coefficient of the denominator. And we'll go over that, what that means again. But in layman's terms, it just means the number that's with the highest power on both the numerator and denominator. And the other case you have a horizontal asymptote is when you have the degree of the numerator is less than the degree of the denominator. In that case, you would have y equals 0. Okay. And one more thing to mention here, in terms of horizontal asymptotes for rational functions, that's it. And there's no other cases. I get this question though about what I've heard of when the degree of the numerator is 1 degree higher than the denominator. So an example here is y equals 2x cubed plus x, that quantity divided by quantity 4x squared minus 1. The highest power is on the numerator is 3, on the denominator is 2. You do not have a horizontal asymptote. What you have is what we call an oblique asymptote. Basically, an oblique asymptote is like a line that has a non-zero slope here, and it's not vertical, so it's basically something along these lines right here. That's what an oblique asymptote is, and that only happens when the degree of the numerator is 1 higher than the degree of the denominator. Okay, so I just wanted to point that out, but it is not a horizontal asymptote. Okay, so let's go back to our example here, and we have a couple choices here. we can either work with the original one, the 2x squared minus 7x plus 5, or we can actually work with the simplified version. It actually doesn't matter for the horizontal asymptote. Let me write both of those versions here. So we had 2x minus 5 over x minus 7. So either one works for the horizontal asymptote. And I'm going to use the original one here. And we're going to look at our, first of all, our degrees. So for our degrees, the degree of the numerator is 2 because the highest power is 2 because of that x squared. And for the denominator, the highest power is 2 as well because of that 1x squared. And therefore, because the degrees are the same on the numerator and denominator, the horizontal asymptote will be equal to the leading coefficients over each other. So my first leading coefficient would be 2, and the one on the denominator would be 1. So 2 over 1 or just 2 is your horizontal asymptote. If you had used 2x minus 5 or x minus 7, same exact answer. You would have leading coefficients of 2 and 1 here again, because the leading powers on the numerator and denominator are both 1, they're the same. So you just take the coefficients of the numerator over the denominator, 2 or 1, 2. And there you go, and that's your horizontal asymptote. Okay, and pretty much this always works out for rational functions. The rules, though, do not work with things that are not rational functions. Let me just make a note of that necessarily. So a lot of people like start applying, for example, the stuff about finding horizontal asymptotes to functions involving something with an e and a sign, like a rational type function. That this is not rational, though. The reason, like the one that I wrote here, rational functions are polynomial over polynomial. This is not the division of two polynomials. It's just a quotient of two functions, is what it is. But those rules that I went over would not apply here. Okay, so just please be aware of that. Okay, well, I hope this helps. Thank you for your time.